Hello viewers, today we're going to be repairing this 16-inch Galaxy oscillating fan, or actually I don't really know what the brand would have been, if it's Galaxy or Lasko or a store brand. This is Russ's fan. I believe he said this belonged to his grandmother and he wanted me to see if I could get it going again. It's completely locked up. I can't even turn the shaft by hand, and the thermal fuse is gone. So we're gonna have to at bare minimum free up the bearings and replace the thermal fuse. Now, since this has sentimental value to it, we'll do a couple of other things. I'll do as much as I can to try to preserve this for as long as possible. There's a couple parts in the windings here in the back. I don't know if you can see that on the video, but there's a couple parts in the windings that are a little bit loose. Where is it? Right here. See that wire move in there? The copper should not move like that, because that will, as the fan runs, see that copper moving towards the center of the screen? As the fan runs and it vibrates, the copper will move around and wear off the varnish that's on there, and that's when you get a motor burnout condition. So we'll go through the whole stator and we'll check the windings for other areas like that which could be a problem, and we'll correct that, and we'll lubricate everything else. Unfortunately, I don't have the blade or anything here to give it a good running test, but as long as we get the motor to run and freed up, I don't see any reason why there would be an issue. So, let's see if I can break this free at all. I don't know if I'm going to be able to. Okay, I can. It's not... Wow. That's incredibly tight. I don't think I've ever worked on one that's this tight. Wow. Huh. That's unusual. These don't typically lock up. Wow. Okay. So wow. Oh, we got some work cut out for us here. Now this piece is supposed to be rubber, and it's very hard and it's chipping apart. So this, I wonder if this failed while it was running, because there is evidence of this getting extremely hot. Yeah, this is supposed to be rubber, not a plastic like that. What that is, that's kind of weird. I haven't seen too many of them like that. So the bearings, interestingly enough, they don't look dried out. In fact, the oil wick appears to be completely full of oil to me. So I wonder if our trouble area is in the back. I'm going to start with dripping some oil down the shaft here. We really got to try to free this up, because I need to turn the shaft to clean this part here, because I'm not going to slide all this rust spots and whatever through the surface of the bearing, because that'll ruin it. So we need this to run before I open it up to do the thermal fuse repair, and we'll just bypass the thermal fuse to do that. Let's see if it shows any signs of taking in that oil. Quite possibly the problem is in the back. Yeah, it's not taking it. Let's go in through the back and see what we can do here. So we have We got our lead wires here. We got our capacitor. We'll check the capacitor too and make sure that's good. I don't have any on hand, but I can always advise him to consider replacing it at a later date. This is a later model. This is probably a late 80s unit, so the capacitor is probably still fine, but it is getting to the point where these capacitors are becoming, 30 plus years old, and they're eventually going to start having problems, even though they have been very reliable. So this is a little bit of an interesting design here. Oftentimes these have a plastic gearbox where the oscillation mechanism attaches, but this one looks like the oscillation area is just part of the motor. Yeah, these things were on the market for so many years. There are quite a few different designs, and so even though they're all the same model in theory, they're not the same on the inside. So this is a piece to be careful with. There's two small little balls inside there. They're spring loaded, and when those come out, they fly across the room, and it's a pain in the rear. So this is all dried out here and burnt. So there's more evidence that this got extremely hot at some point. Now this has got some hours on it for sure. There's a visible wear on the washer in there. But again, there is still oil. So this is kind of a weird scenario. I almost am starting to wonder if the shaft is out of alignment or something. Well, let's throw some oil down the back, and then we'll check out the alignment maybe too. I'm going to go ahead and put a vise on the front here just to give me something to grab the shafts with a little bit easier. Wow, this is really bad. Gotta get that oil to start working its way into the shaft. I think that the problem is in the rear bearing, because now it's starting to free up a little bit. Not much, but a little bit. What might have happened is perhaps some of the grease from the oscillation mechanism might have gotten into the bearing, and that might have hardened and dried up, and that might be what's causing our problem. case this is some kind of an alignment issue, let's go ahead and break the seal on these bolts here. Did not make any immediate difference. Nope, it's not an alignment issue. It's just the bearings are that locked up. Oh man, this is still not anywhere near to the point I need it to be to get it running. This is not good. This is not good at all. Well, I'm going to try to pull the back off, which is, I don't like to work on it with the back removed because now you're going to have a risk of the the lead wires to the windings just kind of hanging around and potentially having a lot of force on them, which of course is no good. But I'm not getting anywhere as we are right now. Huh. So it is the back. That's kind of what I suspected. The back is the bearing is locked up. And is it ever locked up? Wow. Now we just have to very, very slowly, with little to no horizontal force, work this off. Okay, so we've got the back off now, and that can just kind of hang down there like that. And now we got to figure out what the heck is wrong with this. Wow. Yep, that's exactly what I thought it was. It's a very thick and sticky film on the shaft, which is probably this grease. So I'll get some thicker towels and we'll clean this up, and then once I clean that up, I should be able to put it back on and get it to turn on. I might need to turn this shaft in a lathe to surface, get this cleaned up, because it's all, there's definitely some scoring on there. You know, who knows how many hours it ran before, before it locked up. Right, so it's been running under conditions where it's locked or in very bad shape for probably quite some time. Much better. Okay, so now we can get it to run, and I can go ahead and clean off the shaft here. Do I have any sandpaper on hand? No. Ah, jeez. I don't think I have any here. Well, let's see what I can do without it. Before we do that, we're gonna go ahead and I'm gonna have to. I think I'm gonna have to sand it down. It's not quite right. Not good. I wonder if I have some somewhere else. Well, I'll have to figure that out off video. But anyways, we're gonna remove the blade alignment thingy, whatever that's called, before we proceed. I found some sanding paper. So now we got to deal with this electrical situation here, where the thermal fuse does not work anymore. So we're just going to bypass it for now. So we're going to take these two wires and just jumper them together to avoid the fuse. Okay, so this should allow us to get the fan to run. So we'll use that connection to turn the fan on, and then we'll clean up the shaft here. And then once I get the shaft all cleaned up, then we should be able to slide it out, and everything should become copacetic again. it runs. Doesn't sound the greatest, but we'll take care of that. Alright, now we have a nice clean surface area that I'm comfortable pulling the bearing over. Run to the speeds right quick to discharge the capacitor. And now we're going to disconnect everything again. Okay, so I think that the shaft should just slide right out now. Perfect. So now we can see what our problem is. The front, there's a little bit of scoring, but nothing too crazy. The back, actually it's not as bad as it looks. It's not as good as it should be, but it's not, right there isn't too good. But I don't think it's beyond usability. It looks scored, but it actually doesn't feel that bad. I can't really detect any major gouges in the shaft there, so I think we'll be okay. Same thing up front. There's no major gouges in the shaft up here, so it looks awful, but I think we'll be able to salvage it just fine. So we got a couple of thrust washers here. or maybe it's just one. I'll take that off. Then we're going to clean this thing thoroughly here. Get all the remnants of this old grease off of here. That was definitely a film from the oscillation box gears grease. Somehow that got into the shaft and just caused it to lock up. Alright, so we've got that nice and cleaned up. Clean out this thrust washer here, and what we'll do, a little trick, is I'll turn it around, because this way the wear that's on one side, see, it was two. So we could actually do this 4 times. We can turn these around so that the worn part, you can see that there's wear on this side of it and there's no wear on the other side. So if you turn it over, it's like a brand new situation. We'll get all these cleaned up, all that grease off of there. Okay. And so that's the worn side there, so we're going to turn it around and stick it on this way. And this one will go on this way. So that's that. That side's cleaned up. The front I don't think was ever locked up, but we'll go ahead and clean it as well. And then we got to go through the bearings. There definitely is oil on the wick there, but we'll go ahead and add some more. Get some fresh oil in there. Okay, that should be good for the front. And this is a very interesting design. This is not typical as far as I know it. Okay. A little bit of oil in here, even though there's already quite a bit from... It looks like some of the oil, the wicking material is missing, which is kind of weird. That's really quite odd. I wonder where it went. You never know what you're going to see inside these things. Alright, now let's take a look at the fuse replacement. Now we're going to get this thermal fuse replaced. This will be pretty easy because we have two regular leads that we can solder to, as opposed to sometimes you have to solder directly to the winding wire, which is kind of a pain in the neck because it's not really meant to be used that way. So I have new thermal fuse here. These fuses are where are they? Here they are. These are just cheap, cheesy Chinese ones. It's like all you can get nowadays. So they work. I know they work because sometimes you trip them doing the soldering. These are, what's the spec on these? I think it would say somewhere, but it doesn't. These are 115 degrees Celsius, which I think is somewhere around, who am I kidding? I have no idea. I don't use Celsius. I think it's somewhere around 180, which is typically what these are rated for. So we have a decision to make here, which is regarding this old thermal fuse. And I am going to opt to leave it in place, because if you remove it, you're taking out this, and this, which is 4 pieces of string holding the windings together. Plus, this string is varnished to the inside of the winding, which means it might take some force to get it out. And that's force I don't want to execute onto the windings. So even though I'm sure there's going to be people that say, what are you leaving it for? It's sloppy. I'm the tech doing the work. I'm deciding to keep it for the safety of the equipment. So that's my call. I will try to cut these ends back as much as I can. And I'll put, actually, you know what? I'm not going to cut them back. I'm just going to put a piece of shrink tube on there and close it up, just so that it doesn't interfere with anything else in there. Not that it would matter, because it's not going to make any connectivity, but just seal it back up. Okay, so we'll just slip, really could just cut one piece in half. Wonder how much that was actually in the video frame. Duh. Oh gosh. So we'll just go ahead and stick this on here like that. And now we'll isolate it from everything else being able to contact it. Again, not that it would make any difference at all, but I would feel better about it being like this, so that's how we're going to do it. And even this, I'm having a hard time getting it on there because I think it was varnished down. Yeah, there's no way this is coming off of here without messing something up. No way. So I'm just going to leave it. I'm not sure if this is warmed up enough yet. Feels like it's hot. Okay, good. So now we got to find somewhere to bury this new thermal fuse. Actually, I want to check this capacitor too. Make sure that's good. I think, let's see. Where is a good place for this thermal fuse? I can't believe how bad the varnish job on this thing is. There's loose pieces all over the place. Another one down at the bottom here. That's horrible. But not to worry, we'll get it all fixed up. Suppose I could just put it back where it was originally. I could go ahead and just slip it under here like this. I gotta work on that. You know what I'll do? I'll stick it right here. Yeah, that's what I'll do. I'll put it right there. This has a very long lead on it, and I'm going to leave it that way because if you solder too close to it, you'll open the fuse up. Ask me how I know. Alright, let's see what we got here. Maybe something a little bit smaller than that, right? It's the same size. Tisk. Alright, let's see, this is going to be a problem? It sure is. So we're going to have to take the wires off of here, which is fine. I wanted to take them off anyways to check this. So we'll check the capacitor to make sure the capacitance is still what it should be. And this I should be able to slip down in here. At least I would have thought so. Yeah, I'm just gonna cut it. It's kind of a weird setup here with this. Alright, let's measure the capacitance of this to make sure that it's still good. There's no point in patching it up with a garbage capacitor. Really? Okay, 4.2, and this is supposed to be 4, so we'll say that's still good, which is not really surprising to me. Okay, so we're going to connect this wire to the thermal fuse. Some old Radio Shack solder. I sure do miss that store. That was a nice store. Okay, we got a nice connection on there now. And now I can slip this on here. And on the other side, we have to connect. This is a little more tricky. We got to connect to here. Okay, it looks pretty good. And the thermal fuse is not hot, so I don't think that we opened it. So now we can go ahead and pull the string tubing back out of here. Or at least I hope that we can. It seems to have gotten stuck. Just want to make sure there's no sharp edges here. It shouldn't be. I think I covered them all. Yeah, it will look good. Because if there is a sharp edge, it can sometimes puncture through the tubing, and it's not okay. Alright, so I'm not going to shrink the tubing all the way up to the fuse because it'll just trip the fuse. So I'm going to get some tie wraps out, and oh boy, here we go with the commentary. You should use string, you shouldn't use tie wraps. And I don't necessarily disagree with that, but these are rated for 180 degrees. They're electrical high temperature wraps, and I think they'll be fine. This is what I do on my own stuff. I don't have time to sit there and wrap up windings and string and shrink it. I don't have time for that. So I'm going to do this, and it's going to be okay. Okay, so that's copacetic there. And we know that goes to the capacitor, and these two go to the capacitor, which we can go ahead and hook that back up now. This is kind of a strange fix-up here. It's definitely kind of weird, but we'll keep it. There's nothing wrong with it. Definitely one of those times where a third hand would make this task a lot easier. See if I can reuse this solder that's already there. Nope. Alright, I gotta get this cleaned up a little bit here. I don't want to mess with this too much. I'm afraid this tab is just going to break right off. There's not much to it. Come on. Okay, so we should be good here as far as the connections are concerned. Alright, so let's secure this thermal fuse. So let's see how this normally would sit here. So this I think I'm just going to go ahead and stick it right here. Is it going to cause a problem when it closes? It might. Well, I might do something else on second thought. I might just bring it over here and strap it down kind of where the old one was, like this. I might do that. I think that's better. I'll do that. Okay, I think that's pretty good. So we got our new fuse right there, right up against the winding. If it, oh, for heaven's sakes, we got the new fuse there, right up against the winding, and that should be good. So now let's go ahead and throw it back together right quick just to make sure it runs, and then we'll proceed with cleaning up the windings a little bit, taking care of the loose spots. Just want to check to make sure everything's operational first. Another flood watch? Oh, for heaven's sakes. Oh, the stinking flood last week. I gotta go through another flood again. Well, sometimes that's life. You know what you do, you clean it up and move on. Alright, so now we got new fuse, clean bearings. The bearing's not lubricated, so we're not going to run it for more than a second just to make sure everything works. But it should be okay. Okay. Look at them bearings glide. Alright. Gosh, I gotta make it to the rest of the video here. Alright, so we're done with the soldering iron. We'll shut that off. Okay. So that was a successful repair. Now we gotta take a look at the windings here and figure out what we can do about all these spots that it's coming apart. This right here is the most stressful part of this operation, because if you nick these windings with the edge of the motor shell here, you got big trouble. Can't figure out why this. There's some particular angle that this goes through real easy, but I got it the first time, not even trying. There we go. Okay, so the front of the windings we can't work with unless I separate this whole thingamajig from the front, which I don't really want to do, because that's just getting really invasive. So let's just look around here right quick and see. That's a trouble area right there for sure. We got one trouble area, and it looks like it's it. So we just got one issue on the front here, which is actually pretty severe. That whole wire right here, the one that's sticking up, is just floating around in here. This one right here. That's not good. So we got to tether that down somehow. Which is going to be very difficult to do, because can't really get in there that good with anything to fix it. I can spray some varnish in there and hope for the best. I'd like to get a wrap around there if possible. Let's see what I can do. Oh, more tie wraps? Yep, more tie wraps. Here we go. I'm actually surprised this is as shoddy as it is. These are usually pretty good. I can't get it through there. No, that's too tight. Well, I'll spray the varnish, and you know, it's probably, you'll be okay. It's only one wire, Try to push it down as best I can here, and then we'll varnish it. And on the back here, let's see what we got. We have this, which is crazy. I can't believe this is like this. That is ridiculous. Because that right there, that would be the failure point where this scrapes up against the two wires. This here, if this moves at all, come on, get in the video frame. If this moves around like this, it's going to wear off the varnish. Why this is not under that piece of string there is beyond me. It really should have been. Now, because it wasn't put under the string, I'm going to put it under a tie wrap. Okay, that's on there pretty good now. And I think there was somewhere else I saw that was a problem. Was it this right here? No, that's good. Was it under here? Ah, it was right here, yeah, this one. Right there, yep, that's no good there. Okay, I think that was all the areas that were having a problem. Alright, I think it's time to put it back together. Everything else in there looks pretty good. Let's put one more shot of this over here, I think. Alright, so now what we're going to do is we'll put a couple drops of oil on the shaft as we slide it in, and that'll be it. We'll be done here. Wow, there's a lot of warnings in that thing today. Bro, what the heck? Wow, look at these bearings glide. Those are some happy bearings now. Nice. Alright, let's see how this runs. Beautiful. Okay, so now it's going to take some time for that varnish to dry, a couple days. Not really worried about it. Not going to be running the fan anytime soon. Push this back down. This has got evidence of getting super hot too. Wow. I think it's okay still, but that might be something to consider replacing in the future. I don't have any of the correct grease on hand for this, so I'm just going to let him know that he's got to do something with in terms of the grease. Just drop some grease. Now I'm going to go clean this off because I don't want that stuff getting back into the shaft. Oh, whoops, forgot to put that back. Thought something was a little off there. That's what it was. Very nice. This thing looks like it's taken a beating over the years. What the heck? Alright, let me grab the blade from mine and we'll just give it a quick test with my blade just to make sure it's running good. Or actually I have a 16-inch blade right here. It's not the correct one, but it will give us a test. Or it might not fit. Nope, it's too new. The shaft size is too small. I don't know where mine is. I have a feeling it's back behind all those boxes. So, on second thought, we're not going to test it with a blade. What I will do just to make sure the readings are kind of reasonable is I'll just kind of hold the shaft a little bit just to create some resistance on it. So we're looking at 0.23 amps. These are powerful. 0.4, that's pretty reasonable. Yeah, 0.5, 0.6. Perfect. It's working good. And those bearings are very, very happy. And I'm sure Russ will be as well to have this fan working once again.